Well, hello everyone. As Bill put it yesterday in his keynote speech, the physical world is not going to vanish. That's exactly the main idea of our visualization, because we deal with space, we deal with time, things happen both in time and space, and more often there is a connection or correlation between these two dimensions, and our idea was to get a grip on it. We did so within the Europeana Connect program with our partners from the University of Leipzig, the Department for Visual Computing, and I'm from the University State and Library in Göttingen. So we know information layers on maps for some time now. This is a Google map with some information layer above it, and we also know things like timeline. We've seen lots of these in our first panel today. And our idea was, okay, let's those two put things together, like something like this over here. And then add a whole bunch of extra features to get it interactive, to get it explorative, so that people really can play with it and can ask questions to complex data and see how they interact at the same time in space and time. And what we came up with is something like this. It may look a little bit crowded, but I will show you and demo it to you so you get the hang on it. The whole application is a web service, so this is just a browser. We prefer Google Chrome, but Firefox or Safari will do also just fine. I will just switch to full screen mode to have a little more place here. So this is a map of Europe quite easily, and now I have a real-time search connection to the Europeana data repository. And one of the best sample sets for this is the so-called watermarks collection. So if I search now for watermarks, again, this is a real-time search. I will get about 1,000 hits. I hope so. I see. Thank you very much. Watermarks, here we are. Okay, and this is our result set for the whole collection it is. We see that we have a center here in the center of Europe, around about Germany and the Netherlands, and now we have a histogram on a timeline down here. And if I move the mouse over the timeline, you can see that there is some feedback on the map over there. So if I choose a specific year like 1470, you can see, okay, these are 91 scans of watermarks in the collection, and they are from these places on the map. And now you can make a range, something like this, move it over the timeline and see how the popularity of watermarks spreads all over Europe. An interesting thing you will want to try is to add some motive to it. For instance, the lily. Now another color comes in. It's yellow this time. I will throw away the other data sets. You can see that you can combine different data sets here. And with this lily set, we have some... Oh, I don't like the color. Just have to reset the application. Just 1 second. Yellow is the worst one. You don't have that much good colors for visualization purposes. So orange is way better. You can clearly see that there's a huge peak over here. And this peak is centered all around the Netherlands. If you move to the left, so go back in time, you can see that it all starts in Italy and then spreads all over Europe. Here we have a quite interesting diagonal line going through the northeastern part. Then this huge peak over here, and then it fades out all over Europe. You can add some feather over here to have a smooth animation in time, and you can even make connections. So the nearest neighbors in time get a connection here. You can see it starts in Italy, then spreads to the Netherlands, and then we have some strong focus here in the center of Europe. And now if you use the same collection but another motive, for instance, the snake, or Schlange in German, you will see that the success story of this watermark is somewhat different from the first one, both in time and in space. Because we have the peak starts here at 5012, while it's here, 50 years earlier. And also on the geographic layer, we have a really different feeling to the data. Because if you take it like this, the eastern part of Europe is dominated by the snake, while the left one by the lily, so to say. Interesting thing about metadata in the Europeana, multilingualism is still a problem, still an issue here. So if I add snake, which is semantically the same as or serpent, we will get another result set. That's the green one over here. So the data of snake and Schlange are not really the same. They behave differently. And the thing is that we developed this for the Europeana, and now I can try to make some crazy stuff like let's search for a river. So the idea was, well, let's go for Rhine, for instance. Okay, this is the result set, and I will do the German term Rhine also. And we can see the same thing that happened before, that we have two different sets here. So multilingualism is an issue. We have the English term and French term Rhine has a huge dot over here, while the German term is spread all over the map. So my initial expectations that I wanted to see pictures of the river Rhine really wasn't the result case here. If you scroll down, you can always see the actual result set, which consists of this plot of the map and the timeline over here. And you can see, okay, there are a lot of watermarks, for instance. So somewhere there has to be Rhine in the metadata of the watermarks too. We can ease this situation by adding a semantic layer, by adding a where search. So I will search for a place like Rhine, and then things get a little bit better. I will get rid of the two old sets. Yeah, large pictures here. And now I can see, okay, all the dots on the right side has gone away, and we have something that at least mimics the area where the Rhine actually is. You may switch the map to something like Google Satellite to see, okay, there really is something like a connection here between the river and the geographic data. Oh, it's very dark here. Maybe you switch to another, something like this. Next thing we did is, okay, let's open this for all kinds of other data. So we are able to not just ask the Europeana, but deal with custom data we assembled. The data format behind this is KML. I will address this later on. For instance, here I have a set which is called museums, and which shows us all the museums of the world, when they have been founded and where they have been founded. We can see, okay, the first museum of the world was at the Vaticanum in Rome. Then there was long time, well, no really boost in museums, but then things really started in the middle of the 19th century. So this is not data from the Europeana, but from Wikipedia, actually. We use the DBpedia connection to get the semantic correct data. And now you can select, for instance, a country over here and say, okay, I'm just interested in the museums in Germany. So you will select them and can make a drill down here, okay, these are the German museums. Or you may choose to build something like a freeform polygon over here. I'm just interested in the museums in this area. just show them to me and make a new set just out of this collection over here. And boom, you have it, just new color, new curve. So scientists or journalists can really interactively deal with this data. They don't have to go to the data table to change things and make selections, but can do so both on the time scale and on the map. What is the data model behind this? Now I went to my presentation. Here are some other examples: football players of Germany and where they are, of Europe and where they are born, the museums. These are data sets we already integrated, which are the Europeana, our library catalog, Flickr data, IMDb data, the International Movie Database, DBpedia, German Digital Library, and we even put some WikiLeaks stuff in it, the Iraqi war logs and Afghanistan war log files. This is the framework we use. It's all open source. The application itself is open source also, and you can download it on the Europeana code repository. As you can see, we use a lot of common technologies to achieve this. And this is the data model. It's very, very simple. Just one moment. I will tweak the beamer just a bit so you can see something here. No, there we go. Okay. Okay, first thing is the event itself, the what. Here we just need a name. You may add a description and may add an URL. In case of the Europeana files, we added thumbnails of pictures. Basically, you can throw everything in HTML at the what dimension. Then we need a where. Important is we need exact coordinates. So just place names won't do. You have to use a gazetteer to get the exact coordinates. And the last thing is the when, which may be a timestamp or a time range. So you can plot events when they started and when they ended. And all of this is bound together in a simple XML file, KML, the same that Google uses for his Google Earth application. And this is just a snippet of the data. So here you have the place mark of just one dot with the description, the point, the timestamp. Very, very easy to build your own data and throw it at this application. And so what we really would love to see is some connectors to other data sources to this Europeana visualization. For instance, Twitter. So imagine you have a hashtag search and then get real-time visualization how a new Twitter hashtag of an event, for instance, spreads all over the world within minutes. So not years or days, but really minutes or even seconds. Would be quite easy to achieve. I would love to see a generic Sparkle interface to DBpedia so that we don't have to render all the time, but do it in real time. Flickr real-time API, Foursquare to map your life on the map, just like Facebook does, but with your own data and just you have your data. LinkedIn, and so on and so forth. So I think there is a lot of potential here. Maybe we could use one of the forthcoming Europeana hack events to build some of these connectors here. And the final step we did in terms of dissemination is that you can actually throw your own data into the actual application. And it's very easy. You just have to look up the specification, build your own KML data set, and put it into our existing web application. I will show this to you. So here I have the file. It's the museum dataset actually, just plain XML. And I uploaded it to a web server, which is over here. Just my web server. I'll copy the URL, go into the prototype, clear the data, choose KML file URL, just put the URL into it and say open. And there it is. Your data in the application within, well, just a few seconds. So if you're able to build this kind of data, you can reuse it right here, right now. So this was one of our basic ideas, not to have a very complicated application where you have to install things and solve dependencies, but really you can just go on and play with your data very soon. Last thing we did is to set up an information page. You can, I'll show the URL. We have made some YouTube clips over here where you can see in 5 minutes, okay, these are the basic features. We have a feature description page. We have some sample data sets that focus on different aspects of our application. So you can see what different kind of questions you can solve. And we have a resources page where you get the data format, can see some example data sets to build your own ones. This whole thing is up for, well, 2 months now, and by now reception by the broad public has been modest, to say the least. So I would really like to see some more publicity here. So on my speech in May, I urged you not to Twitter anything about the URL because it was still beta. We are now out of beta. We are up and running, so you may, or I would very much like to see this URL over here, tinyurl e4d project, to be published and to be spread all over the world. That's it. Thank you very much.